So my research project is on the effect of food exposure type on the development of HUS in individuals diagnosed with, oh, it's supposed to be STEC, diagnosed with STEC in MN from 2010 through 2019. It's not letting me.
Take your time. Don't worry.
I think I'm just going to keep it like this because it's not letting me move to the next slide when I'm presenting.
No problem.
Okay, so I'll begin with the background. So Shiga toxin-producing E. coli, or STEC, are infamous strains found in the environment that produce toxins that attack blood vessels, killing intestinal cells. These Shiga toxins can also cause the development of hemolytic uremic syndrome, which is known as HUS, in approximately 2 to 15% of E. coli 0157 cases. STEC can be transmitted to humans through various transmission sources, such as human-to-human contact, travel, water, animal contact, and food items. And STEC can also express two families of the Shiga toxin or STX gene, including STX1 and STX2. And researchers have found that STEC strains that produce only the STX2 subtype have a higher risk of causing HUS than STEC strains that contain both the STX1A and STX2A subtype, or solely the STX1 subtype. So this discovery is significant because it shows how STX genotype can serve as an effective predictor of whether an individual with STEC develops HUS. So the question my research sought to answer was whether the type of food exposure, such as milk or beef, consumed is predictive of the development of hemolytic uremic syndrome among patients diagnosed with STEC in Minnesota from 2010 through 2019. And to answer this question, I looked at both the STX genotype proportions and the relative risk of HUS for food exposure types. I'll explain what relative risk means later on. So in order to answer this question, it was necessary to use quantitative research methods. Specifically, secondary data collection and analysis was used, as well as descriptive statistics. Secondary data collection and analysis permitted the use of the 2010 through 2019 STEC dataset from the Minnesota Department of Health to obtain information on the foods patients ate, as well as like the STEC genotypes. The development of descriptive statistics also facilitated the analysis of the information I obtained through secondary data collection and analysis. Specifically, I used the descriptive statistics to create graphs that represented the STEC genotype distribution, as well as the relative risk of HUS for the different food exposures I was looking at. Okay. So in the end, it was found that consuming eggs or any greens led to a decrease in the risk of HUS, and that consuming raw milk or milk leads to an increase in the risk of developing HUS. Okay. So now I'll be going over how I came to my conclusion, focusing first on the statistically significant results. So before I get into my results, I'll just go over how to interpret this graph. So this graph is basically just showing the STX proportion on this side, and as well as the relative risk over here. The relative risk is the ratio of the risk of developing HUS for those who had the food exposure or consumed the food to the risk of developing HUS for those who didn't have the food exposure, or just people who just didn't consume the food. So looking at the eggs, the no eggs represents those who had STEC but didn't consume eggs, and eggs represents those who had STEC and did consume eggs. Okay, so beginning with the eggs food type, the relative risk was determined to be 0.4919. So this means that there's about a 50.8% decrease in the risk of developing HUS for those who consume eggs compared to those who don't. When looking at the STX genotype proportions to predict risk, it was found that 41.9% of people who are diagnosed with STEC and consumed eggs had the STX1 genotype, whereas only 34.2% of people who were diagnosed with STEC and didn't consume eggs had the STX1 genotype. And as mentioned earlier, STX1 causes less severe disease, so one would expect the risk of HUS to be less for those who consume eggs compared to those who don't. Okay, and moving on to the any greens food type, the relative risk was determined to be 0.3820, and this reveals that there's about a 61.8% decrease in the risk of developing HUS for those who consume any greens compared to those who don't. The STX genotype proportions are relatively similar between those who had STEC and consumed any greens and those who had STEC and didn't consume any greens, so not much can be said about the HUS risk by looking at the genotypes. So now on to the raw milk food type. The relative risk was found to be 4.138, and this is the most prominent relative risk I found, and it basically shows how there's a 314% increase in the risk of developing HUS for those who consume raw milk compared to those who don't. So obviously there's a very large increase, and when you look at the STX genotype proportions, it's not very useful because the proportions are relatively similar between those who did consume raw milk and those who didn't. Trying to go to the next one. Oops. Is this? Sorry, one second. Okay, and now on to the milk exposure type. The relative risk was 1.471. So this is a 47.1% increase in the risk of developing HUS. And once again, the STX genotype proportions aren't very useful because they're relatively similar between those who had the exposure and those who didn't. So that covers all the statistically significant results I found. And now I'll just be going over other interesting findings that weren't statistically significant for the relative risk. So for the unpasteurized juice food exposure type, the relative risk was 0.9571. So that means there's about a 4% decrease in the risk of developing HUS for those who consume unpasteurized juice compared to those who don't. It's not statistically significant because the upper confidence interval, or like the UCI, as you can see on the screen, is greater than 1. So if either the LCR or UCI covers 1, then the relative risk isn't statistically significant. So the relative risk can't really, it's not like concrete evidence or like significant to show that it increases or decreases HUS risk. But if you were to look at the STX genotype proportion, there were some interesting findings. Specifically, 61.96% of people who were diagnosed with STEC and consumed unpasteurized juice had the STX1 genotype, whereas only 39.7% of people who were diagnosed with STEC and didn't consume unpasteurized juice had the STX1 genotype. Furthermore, only 25% of people who are diagnosed with STEC and consumed unpasteurized juice had the STX2 genotype, whereas 30.7% of people who are diagnosed with STEC and didn't consume unpasteurized juice had the STX2 genotype. So the higher proportion of STX2 genotype and lower proportion of STX1 genotype for those who didn't consume unpasteurized juice may lead some to believe that the development of HUS is greater for those who don't consume unpasteurized juice compared to those who do consume unpasteurized juice. Okay. And for both beef and ground beef, the STX genotype proportions are pretty much the same. So it's not a good predictor of HUS risk. However, even though the relative risks weren't statistically significant, they showed how there is a 10% decrease in the risk of developing HUS for both beef and ground beef. So further research would be useful in exploring whether there really is a decrease in the risk of developing HUS. Okay, so onto the cheese exposure type, approximately 42.3% of people who are diagnosed with STEC and ate cheese had the STX1 genotype, whereas only 29.89% of people who are diagnosed with STEC and didn't eat cheese had the STX1 genotype. The relative risk for the cheese exposure type is 0.654. So while the relative risk isn't statistically significant, the 34.6% decrease it reveals in the risk of developing HUS for those who consume cheese compared to those who don't is supported by the fact that a larger percentage of people who are diagnosed with STEC and ate cheese had the STX1 genotype than those who didn't eat cheese. And just to say it again, STX1 causes less severe disease, so there's a lower risk of developing HUS than if they had the STX2 genotype. And lastly, for the raw cheese food exposure type, 55.9% of people who are diagnosed with STEC and ate raw cheese had the STX1 genotype, whereas only 37.3% of people who are diagnosed with STEC and didn't eat raw cheese had the STX1 genotype. Furthermore, only 24.4% of people who are diagnosed with STEC and ate raw cheese had the STX2 genotype, whereas 31.7% of people who are diagnosed with STEC and didn't eat raw cheese had the STX2 genotype. Looking at the STX genotypes, it raises a question of whether those who ate raw cheese had a lower risk of developing HUS, since the STX2 genotype is associated with HUS. And according to the relative risk, which is 0.598, there is a 40.2% decrease in the risk of developing HUS. But once again, this isn't statistically significant, so more research needs to be done. So now on to the implications of my conclusion. So the researchers in the field of STEC can build off of this study by conducting similar studies in different regions and exploring whether certain food exposure sources are repeatedly associated with a decrease or increase in the risk of developing HUS. Furthermore, as I just went through, there were a couple of food exposure types that had relative risks that weren't statistically significant, so researchers could work to fill those gaps. And due to the large increase in the risk of developing HUS in patients with STEC who consume raw milk or just milk, there are several methods that could be taken to curb this risk. Specifically, according to the CDC, states where it's legal to sell raw milk for human consumption have more raw milk-related outbreaks of illness. So a possible step toward decreasing illness from raw milk is to make the sale of raw milk illegal everywhere in the US. On an individual level, people should ensure their milk is pasteurized, and those who work in the dairy industry should keep animals away from the milk in order to prevent animal feces from coming into contact with the milk. So to reflect, this research project took many months. I started out by learning how to code on RStudio. I wrote 20 annotated bibliographies over 5 months, and then while I was writing those, I also cleaned the data sets and went through and looked through what foods people ate. And then I went on to develop the descriptive statistics and make graphs, and then I finally wrote my paper and presented. So it's been a long process, but I learned a lot, and I got to work with a really great mentor, and yeah, it's been really good, and I learned a lot about STEC and about the research process in general. Should I stop sharing?
That would be great.
How do I stop sharing? I don't see. Oh, I see it.
There you go. Excellent.
Great.
Great. Well, Vaishu, so this is the time when you have the opportunity to answer some oral defense questions. You've seen those oral defense questions in advance, and they come from one of 3 different areas: the research process, your depth of understanding, and reflection on the inquiry process. So my first question for you: how did you determine which results generated by a research method were most important in informing your new understanding?
Well, I mostly just, well, first of all, I paid attention to the relative risks that were statistically significant. So I went through and made sure I definitely got those into my research paper and included them. And then I also took a look at the STX genotype proportions and noted down any that were interesting or dramatic enough that I could talk about it. And I included those as well.
As kind of a follow-up to that, given the results you found in terms of which food types were more associated with a particular genotype or not associated with a particular genotype, did you find that that connection provided really helpful, insightful information, or did you find that there wasn't a strong correlation? What do you feel about that piece of your research?
Um, well, I think the relative risk is definitely like the most associated with HUS, like the bigger like predictor of HUS. But STX genotype also offers some important insight, and it can be used as a good indicator of like what's going on with the exposure type. And if it's like a really big difference between the amount of people who had the STX2 genotype compared to those who had the STX1 genotype, between those who had the exposure and those who didn't, it does offer an interesting perspective on like the HUS risk, because if you combined what you notice with STX genotype proportions with the relative risk, and they both kind of led to the same conclusion, it offers more evidence supporting it. So in that case, in that sense, it does. But individually, it can offer some prediction of HUS, but not as well as relative risk could.
Thank you. So my next question for you is, how did the limitations of your method or data influence your new understanding?
Well, the biggest limitation I would say was the fact that the analysis was influenced by selection bias. Specifically, the data used for analysis was gathered from individuals who sought care, got tested, and were reported. So this could have so those who seek care generally have more severe disease. So this could have influenced the STX genotypes that were reported because, as I mentioned, STX2 genotype is more associated with severe disease. So it could have been overrepresented, or like STX1 and the other genotypes could have been underrepresented. So that could have shifted the distribution. So I had to take that into account.
That makes sense. Then finally, what is the most important research skill you developed as a result of this process, and how might you apply that to future endeavors?
I think the most important skill I gained from this was using my resources, whether it was my mentor or my cohort members or just Google. I learned the importance of just like making sure I used all the resources available to me. And whether it could also been like past work. Like when I was writing my research paper, my memos came in handy, and my emails with Dr. Tar, I just went back and looked through because I knew that there was some stuff that I would mention earlier on. So it was important for me to go back and look through them. So that was really helpful for me. And if I do research in the future, I'll make sure to continue using my resources and developing that skill.
Wonderful. Well, that finalizes your presentation with oral defense. Stop recording here.